Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi everyone. In this video, we will discuss the pre-lab module experiment 6, which is about the diffraction grating. The objective of all learning outcomes for this experiment is to determine the wavelength of the laser beam using a diffraction grating and to determine the number of diffraction grating lines per unit length. As usual, in the pre-lab discussion, there are three parts. The first part is introduction. So for this experiment, we will use the laser beam as a ray to form the diffraction pattern. So when this laser beam incidents on the diffraction grating, a diffraction pattern in the form of a series of bright dots can be seen on the screen. So if you need to sketch the diffraction pattern, it is as shown, where the central bright dots is very bright. Beside the central bright, there are first bright fringes, and continuously with the second bright fringe and the third bright fringes at both sides of the diffraction pattern. For question number 4, based on the equation sin theta is equal to n lambda over d, state the meaning of d in the equation. D is actually the distance between the two consecutive lines of the diffraction grating, or we also can say D is a grating spacing. For question number 5, based on the same equation, what is the relationship between the angle theta of n order and the wavelength of the laser beam? So referring to the equation, both of them are directly proportional. And the second part is experiment. For question number 6, what is our manipulative variable in this experiment? So our manipulative variable is the number of order, and the responding variable is the distance between the spot of the order to the center spot, which is represented by L. And our constant variable is the distance between the diffraction grating and the laser PAM. So the distance is around 30 centimeter from the laser pen to the diffraction grating. For question number 7, why we need to adjust the distance t from the diffraction grating to the screen? So we need to adjust the distance t is to make sure that the spacing between the spot on the screen is as far as possible from one another. And then for question number 8, suggest the best way to measure the length of each respective order or diffraction pattern on the screen in procedure 3. So the best way is the length should be measured from the center of the central bright to the center of the respective end fringe. And for the question number 9, how to determine the value of sin theta for order n? So you can refer to the procedure 4, where the equation is sin theta is equal to ln over sert ln square plus d square. The third part for the pre-lab module discussion is about the data analysis. Take a look at question number 10. Write the related equation in order to determine the wavelength of laser beam lambda and the number of lines per millimeter of the grating B. So you can refer equation 6.3 in the theory, which is the equation is sin theta is equal to n lambda. For question number 11, based on the linear graph equation y is equal to mx plus c, write the suitable quantity referring to the equation in question number 10. So referring to the equation in question number 10, y-axis will be represented by sin theta and x-axis will be represent the number of order n, small n. And for question number 12, sketch the suitable graph to show the relationship between the sin theta and order n. Label the graph with suitable symbol and write the title of the graph. So of course, because of our y and x represent here, so our title, the title of the graph is graph sin theta against n. Sin theta at the y component, n is at the x component. And you will get a straight line graph. For question number 13, A, How do we determine the wavelength of laser beam from the graph of sin theta against n? So referring to the graph, firstly we calculate the gradient of the graph, and from the gradient of the graph, the wavelength is equal to the gradient of the graph m divided by n, where the diffraction grating that we will use for the first experiment is n equal to 100 lines per millimeter. For question number 13b, refer to the learning outcome 2. How do we determine the number of lines per millimeter and of grating B from the second graph of sin theta against n? So we do the same thing. From that graph, we calculate the gradient first. And from the gradient of the graph, we will determine the n, the number of lines per millimeter, which is equal to the gradient of the graph m divided by the wavelength. Now, our wavelength is referring to the calculation in question number 13, or you can refer to the procedure 7. Lastly, for question number 14, you need to list 3 precautions from this experiment. So this is the suggestion precaution that you can take before and while doing the experiment. The first one is ensure that the lab room is totally dark to precisely observe diffraction pattern on the screen. Precaution number 2, handle the diffraction grating with the care as it is a delicate component. Precaution 3, do not touch with fingers the surface of diffraction grating to avoid scratch. And lastly, care should be taken so that the reflected laser light is unlikely to enter any eyes. Okay, that's it for the discussion of pre-lab module for the experiment 6 diffraction grating. Thank you so much for watching and listening. I hope you understand and you can prepare yourself to do the experiment. Don't forget to like, share and subscribe my channel. Thank you so much. Thank you and all the best for your PSPM.